SuperCloud Composer offers a switch infrastructure service where network administrators can deploy, manage, and support Ethernet-based switches within its ODIN ecosystem. Within SCC's network module, administrators can perform firmware updates, restart switches, manage a switch firmware repository, or even perform zero-touch provisioning of infra top-of-rack switches. During NOC operations, operators can harvest real-time telemetry and analytics of a switch with just a couple of mouse clicks. Let's dive deeper into the network module and see what we can discover. As you can see here from our switch list, this is a collection of switches that we've actually put into our inventory. You can see here that each of the switches here are blade switches, super micro distributed switches or distribution switches, and then also third-party switches, which are Arista switches. So we can look at various different kinds of metadata that we would want to see or be able to look at a switch. Network administrators would like to look at CAM tables or forwarding databases, be able to do zero-touch provisioning, do pretty much what we call management of the switch itself. So in the top place here, or with the buttons on the top, we can actually perform a switch firmware update here. We can also restart the switch. We can connect in through SSH and also connect in through its web UI, or also look at very detailed information. So let's go ahead and start by looking at the detailed information perhaps of an Arista switch itself. So we click on the element in the table and we simply click on detail. In the detail portion, it provides us with very rich information. Shows us its LLD chassis ID, shows us specifically serial numbers, model, uptime, very useful information for the switch administrator. So let's look a little deeper and say, oh wow, we can do some troubleshooting here to determine who our LLD neighbor is. By simply clicking with one click, you can really see here that the management interface itself is connected. So the console connection of the switch is connected into a super switch, which is a G3648 switch itself. Shows you the interface that we're communicating in the chassis ID. So let's look at its uplink ports, how it's connected. So in port 48, we can also go ahead and look at various detailed information too as well of what's basically connected. So very useful information from a switch perspective of collecting the metadata that we need. Okay, so let's drill down into a little bit more and look at really a blade switch. So if we click here on the blade switch, shows us a nice little image to show what the actual blade switch looks like. Shows you some physical asset information of the switch, such as serial number, firmware information. And what's great about this is it also shows you the uptime and the ports that are up and the ports that are down based on our carousel view. And of course, we have all the various lifecycle management we can do for a switch with the buttons up here that we can basically perform. So I want to also look at the pane or the sidecard information here. You can see here we can look at very detailed information such as MAC address. So in VLAN 1, you see MACs that are showing up in its forwarding database. And you can come up here and change the VLAN. In our case, this is just configured as a default native VLAN, a VLAN 1. You can also go ahead and create VLANs. So if we wanted to create a simple VLAN and we wanted to call it, say, 23, and we wanted to call it, say, vMotion, we can simply go ahead and do that. Whoops, I need to spell vMotion here correctly. And by just one submit command, we automatically successfully now have created a VLAN in VLAN 23 called vMotion for our vMotion traffic to traverse across some ESXi cluster members in a VMware cluster. So these are just very simple ways of creating VLANs themselves. And then we can also go ahead and look deeper into looking at physical information, like what is the ports doing on the switch? Are they in an up status? Are they in a down status? What particular VLANs are associated with them, and so on and so forth. So this information will be very useful here when we want to be able to collect information about what's happening with the switch. You can see we have operational status of down, we have speed, we have MTU size, it's an access port, and then we can also change from the port characteristics by coming into port settings and changing. We need to go ahead and choose a port that we want to make a change to. And so by clicking on port settings, you can go ahead and shut down the port itself, or you can alter flow control or MTU size. So changing characteristics of the port are important to network administrators themselves. So we can also go ahead here and show you on the top here, we don't have really any particular ports that are plugged in, but you can see here from the switch display that all the ports are, no cables are connected. So they are really translucent or transparent. And then if we go ahead and add in a server port, these particular ports would change in color based on if they were an uplink port versus a server port themselves. So we can also look at the logical representation. So for example, if you want to be able to configure lags or MLAGs, we have that kind of support here by creating a lag or an MLAG associated with a switch port itself. And then we also have the ability, which is a very slick GUI engine here, to be able to walk you through entirely configuration of VLANs, plumbing those VLANs out to switch ports, and also allowing certain VLANs to be exposed associated with a .1Q trunk. So all various things that a network administrator would be interested in of actually configuring their environment. And you can see here that we provide the Vlan modes if you want to be able to move, or make changes to VLANs in bulk. You can configure them, say, a whole entire trunk port, where you can now have easily move those by just a click of a mouse and then just hovering over and making those all trunk ports, right? So you have to be careful, obviously, when you do this, because you can certainly really step on a landmine here, but it really provides the network administrator really easy use to be able to configure these switches very quickly and bringing up in the environment. And of course, if you're going ahead and trying to provision a number of switches, you wouldn't typically use the GUI interface in order to do this. You would be able to create a Python script that allows you to speak to our northbound API to configure switches in bulk. So great kind of network module here to help the network administrator save time, and so he doesn't also make mistakes when he's provisioning switches themselves. So the last piece I want to show you is the analytics piece, right, which is really, really important for network operations staff to really get oversight on what's happening with their switches. So we're going to quickly go over to the monitoring details section here, and once we connect over there, we're going to go ahead and search for, let's say an Arista switch is 11.153. I just happen to know that, so we can click on that. And then you can also look at the port counter information of the switch itself. So by going ahead here and okay, so it's a little pokey and coming up here. So if you go down to the bottom here, you'll see here some of the ports are not connected. So we want to kind of traverse down to some traffic that's being generated on a port. So let's paginate through here. I believe it's going to be Ethernet 34. So we see some traffic on Ethernet 34. So let's go back up to here and then just go ahead and have this charted here with the kind of traffic we're seeing on port number 34. So we'll scroll all the way down here and find 34. So keep scrolling. Oops, I went by here. 34. Here it is. Okay, so 34. And then what we'll go ahead and you can see here immediately we're starting to see port counter information. You can see discarded packets, error packets, number of octets, pause frames, things that network administrators would like to see. And then, of course, we have port counter information up here. So we have a differential, and then we have the cumulative. And then if you want to go ahead and you look at basically rates that are happening here, we can simply click on the navigation view here. And by going to navigation, we come to rates. And then what we can basically see is unicast, broadcast, and also multicast packets being charted. We'll go back to 34 again here in our list, which is in because, again, we have traffic that's being generated on port 34. So we'll go ahead and choose that option. Okay. And then so you can see here where we've actually charted through our analytics here of collecting information about the switch. So hopefully this helps you get a perspective and interest in our networking module with SuperCloud Composer.